All right, Assalamu alaikum wa rahmatullahi wa barakatuh. This is Muhammad Al-Adat. I'm an assistant professor at Philadelphia University. I'm going to talk about image segmentation based deep learning for biliary tree diagnosis. Simply, we have an MRI images that we collected from the hospital or King Hussein Medical Center. It's an MRI images that contains a biliary tree. And then we will use the technology of deep neural network in order to segment the biliary tree, extract some features, feed it to the machine learning. So let's see how we did that. So in the beginning, let's talk about the importance of dilation of biliary tree. The dilation of biliary tree, it will be a good indicator if the patient has let's say, some minor diseases such as stones, tumors, or some major diseases such as cancer. So, the dilation may cause due to several reasons, such as like trauma, something hits the patient, or some liver damage. So we have MRI images or magnetic resonance images that have been collected from King Hussein Medical Center. We will use the technology to extract or segment or detect the biliary tree from the MRI image and then extract like several features from it, such as features entropy, standard deviation, RMS. Simply speaking, these are some statistical features. So once we have the features in hand as a data set, these data set we will apply like some pre-processing techniques before feed it to the machine learning. These pre-processing techniques, you can call it like a data science. What we have it now, data science, such as data normalization, data transformation, dealing with empty values, dealing with null values, or dealing with zeros. Some things that will make the data set more robust. So once we have that, or once we do that, or we apply this data set to the machine learning in order to classify if this patient or this person has a dilated bile duct or not. So the contribution of this research is to use deep neural network in order to extract the biliary tree, then extract several features from this segmented image. After that, correlate these features with the dilation of bile duct or biliary tree. All right, it's important to mention that this is the important part actually after dealing with this research, the dataset. The dataset means the MRI images that we applied this research on it is the toughest part because the paperwork, the privacy of patients and the other things, we suffer a lot. So after communicating with some surgeons or doctors, medical doctors from King Hussein Medical Center, they actually agreed to cooperate and like provide us with 800 MRI images, and thankfully they sat with us and they help us in distinguish between the MRI images that contains a patient who suffer from dilated bile duct and other MRI images that they for patients who doesn't suffer from dilated bile. We mention it by calling it not normal bile duct or more normal biliary tree or dilated biliary tree. So thank to them and for their time helping us and downloaded the images and organized them in folders such as, because we are not experts, so they help us and categorize them. It's important to mention that and their efforts. So we have the biliary tree images collected from the King Hussein Medical Center. We label them, and then after that we use CNN segmentation in order to segment the biliary tree. After that, we extract these features, as you can see, like 1, 2, 3, 4, 5, 6, 7 features from the MRI image. We apply some data science on this data set in order to apply it to the machine learning to classify, as you know, to train and test, and after that have like a successful model to see if any new if it can tell or the accuracy was so good that it can tell if the patient has a dilated biliary tree or not, or a dilated bile duct or not, based on these features. And the features are entropy, energy, standard deviation, RMS, etc. So this is the DNCNN or the FCN, fully convolution neural network, or deep neural fully convolution neural networks, more precisely, how the layers of it. So simply it has a ReLU layer. Each ReLU has a convolution layer. Final one, it has a convolution with pooling. Then we have deconvolution to like collect, or let's say gather the pixels together, or the segmented images, small images, or what they call it, patches together, in order to segment the bile duct. Simply speaking, it will tell if this pixels belong to the bile duct or biliary tree or not. If it's belong, it will keep it. If not, it will ignore it, as we will see in the next slide. So in this slide, as you can see, this is the MRI images in the most right. After that, the MATLAB, we use the MATLAB in here to detect the bile duct. The colored image over here is the trained model to detect the biliary tree from the MRI image. Finally, we apply some image processing technique to just take the hugest or the biggest contour, because we may have some noises after the deep neural network. So we get rid of it using the some image processing technique to get with only the bile duct or the region of interest, as you can see in this image. So in the most left, or sorry, the most right column in this image. So after that, we extract features. As we mentioned before, we already have like 400 images or 400 MRI images for people who doesn't or does have normal biliary tree, and other 400 images for people or patient who already has a dilated bile duct. This is the statistical analysis for these two categories. So finally, after we apply the segmentation, extract the bile duct from the or the biliary tree from the MRI image for the two categories, the normal and dilated patients. Extracted the data set. We fed the data set after applying some data science such as normalization, transformation, what else? Dealing with empty values, etc. With these things, we make the data set simply ready. We use the data science to make the data set ready for the machine learning, and we call it like it's a pre-processing technique. So and now it's ready for the to feed it to the machine learning. We use several machine learning techniques. As you can see, we use neural network, support vector machine, KNN, and the decision tree. Actually, most likely in the research or the research people, they decide to use several neural machine learning techniques in order to make a comparison between them. to see which one actually uh, give us like more accuracy on the training and testing result. As you can see, we find that the KNN give us like uh, I think sorry, decision tree. As you can see, decision tree over here give us like it's like 79% 0.6, like something like that. So as you can see, it's give us the best accuracy. It's better than the KNN, K-nearest neighbor, or support vector machine, SVM, or NNN, or NN, it's a neural network. So simply that's the research that I have done so far on this field. Thank you for listening. Hopefully it will be precise and like easy to follow. Thank you for listening. Thank you so much. Okay, so I already answered the first part of the form question. Who is the solution for? And this is the second part. What are your reasons for wanting to participate in LifGlobal? I believe that I can find a new way or new technologies or new solutions that may help the patients, or say, let's say this is my major, which is about medical engineering. So help the doctors, the patients, in order to make their life easier, to come up with like some techniques or tools that will help them uh, do the like diagnosis by themselves. For example, it's not only for the dilation of bile duct, or I'm talking about some other diseases, let's say, for example, the glaucoma, the cancer or skin cancer disease. This is for the biomedical engineering part. I can also use the computer vision technique in order to do some other parts, or to like use the data science technique to help in classification or make some regression like predictions for some other like majors or disciplines. It's easy to handle once you have or once you know how to deal with the technology. So I believe if I get like some good training from the Life Global, I will be able to do or to apply some of my vision on these fields, or these new techniques, or to make some people life easier. Actually, that is my major purpose.